Hello everyone, it's September 4th. We have to enforce the half an hour rule today because I just finished work about half an hour ago. I don't even think it's half an hour ago, maybe 20 minutes ago. Boy, on call is always, just extra time you need. Ooh, look, we have a solution right there on Python. Nonetheless. So we'll just do this as fast as we can. If we cannot figure it out in half an hour, we'll just copy and paste. All right, we have num1, num2. In one operation, you can choose integer I in the range of this and subtract 2 to the I plus num2. Okay, so what we're doing is subtract this from num1 n1 minus 2 to the I plus n2. So that's just n1 minus n2 minus 2 to the I. Return the integer denoting the minimum number of operations needed to make. So that's one operation. Okay, well, this is actually. Okay, so this is just one operation. Right, one operation. Let's say we need k operation. So basically it's n1 minus like the first operation I0, right, minus second operation, right? So so basically n1 minus, let's say we have k n2 and then minus 2 to the I0 plus 2 to the I1 plus 2 to the I2 plus plus 2 to the IK. Right? And what we want to know is to make this into 0, what is the minimum number of k? Sorry, there's a spider, and then my cat had already tore off like 2 legs of the spider. And I think the spider will survive. I always have a very soft spot for spider. I really like spider. Anyway, so yeah, so we have this minimal number, and I can range from this. Well. And num2 can be positive or negative. Well, if n2 is a positive number, if n2 is a positive number, well, we know the minimum. If n2 is 0, we know exactly how many we need. Right? We know exactly how many we need. Now, n2 is now not 0. So the minimum we need, so basically, we need to find for this I can do the binary, and that's the number we're gonna be here. So essentially we want to know what is the minimum number to, actually that's not right? So we need a k to equal to this, the number. But in this case, k is 3. So 3 plus 6 actually equal to 9. Right? But 9 is 1, 0, 0, 1. This is 9. Right, so we have k is equal to 3, but this will only have 2 bits. But it's fine because each one can be split into 2. Right? So that's okay. 1 can turn into 2. Because this, I can basically say break it down into 2 of this. Right? 2 of this. And then, so everyone can turn into 2. Everyone can turn into 2. So okay, so we just do 1 by 1. Like, so how about 1? 1 will be 5. 5 is 1, 0, 1. So k equal to 1. So if we have more this than this, then it's not possible. But if we have, if k is larger or equal to this, it's always going to be possible, right? As long as k is larger or equal to the number of bits. If it's 1 larger, we do it. If it's 2 larger, we essentially get 2. Unless it's just 1. Because if it's just 1, yeah, you can't do much if it's just 1. So it has to be, oh, so do we have to also, so it's not just larger or equal to, right? So it depends on what value it is. Yeah, if we have like 2, and then it doesn't allow you to get 0. That's the bad part. The minimum is 1, right? The minimum is 1. So we have to check the number itself, right? And the number itself must be larger than the minimum. So like if I have k is equal to something, and then the minimum of this is going to be equal to k. So the number has to be larger than k, right? If the number is not larger than k, then just it's not possible. So we have the number, we have this, and we can always break it down into some stuff. And you can always do 1. Yeah, I think as long as it's larger, then it's always possible, right? If k is equal to if k is equal to this value, this is the difference, then if it's 1 more, then you do that and you have a 2, right? So you can always break it down and I'm trying just to see is it possible? Like as long as k is larger or equal to n1 minus k times n2, we can always find a way to form this. That's the premise, right? If k is larger than this, that's not true. No. It's k need to smaller or equal to this. K needs to be smaller or equal to, because if k is too big, k needs to be smaller or equal to this. So when it's equal to 1, right? So k is 1, and this is a 5. That's good, but we have 2. The minimum is 2, so that's no good. So when k is 2, this is 7. 7, the minimum is 3. That's no good. So now k equal to 3, this is 9. 9 is 1001, so I have 2. So k is larger than the number of bits. The number of bits, right? So k is larger than the number of bits. Larger or equal to the number of bits. And if k is equal to the number of bits, yes. If k is larger equal to number of bits, right? And then I have the worry that so k needs larger than the number of bits. At the same time, right, k need to also smaller or equal to n1 minus k times n2. Because k larger than this is a possibility, but we have like if it's just 1, right? So because we do k times, so the minimum is going to be k, right? So this cannot be smaller than k. So this has to be larger or equal to k. So my question is, when this is available, is that the signal that we can get it? Right, we can get it. So k is larger than the number of bits, okay? And then k is smaller or equal to this value. And then this is this value is this, right? So we have a big value which has smaller number of bits than that. So it's bigger value than this, and that means we have always something, right? We have something, and then we can always break it down. Yeah, I'm not sure if it's always possible. Is it always possible? Is it always possible? I feel like it's possible, otherwise, but I cannot prove it. And when is it not possible anymore? When this one when k becomes smaller than this, that's I think when it's not possible. No, when k becomes bigger than this, that's not possible because you keep removing, right? So if n2 is a positive value, then the value just keep going down. So at a certain point, k will be bigger. That's when it's not possible. Yeah. So that's good. And I want to say the first time that this is possible I feel like there might be some edge cases. I cannot prove it. I cannot prove it. So I have a value bigger than k. Okay? I have a value bigger than k. The number of bits in there is uncertain. It could be just 1 bit. Right? I mean, the least possibility is 1 bit. We can actually give a shot, like let's say 1 bit 16, right? 1 0 8. Okay, 8 is a 1 bit. K equal to 1, yes. K equal to 2, yes. K equal to 3. Well, we can break it down. So break it down. It become 2, and then 1 can keep break it down, right? So how about k equal to 7? Well, k equal to 7, I need 7 to get to this. So yeah, 6 plus 2. That's 7. Okay, and 6 is 1, and then have this as another 1. Yeah, it does feel like it's possible. So what if it's 6? I need 6 to get there. So basically for this, for 6, I say I can do one of this. Right, I'm gonna do 2, no, it's 2 plus 6, so we need 5 to make 6. Yeah, we can use 5 to make 6. So we do 4. Yeah, I feel like it's possible. I still don't have a good proof. I don't have a proof, but I think this shall work. We'll give it a shot. We'll give it a shot. I don't have good proof. I feel it will work, but I don't have good proof. What the hell is this? Did I? Me God. Alright, anyway, let's do this. I don't have good proof, but I think what we want is to find the first k such that num1 minus num2 times k is large equal to k, and k is smaller then number of bits in num1 minus num2 times k. Small equal to. We can loop through k, and the termination is when num1 minus num2 times k is smaller than k. But again, yeah, I don't have good proof. I do not have good proof. Rest equal to 0 while k equal to 1. We have to start with 1, right? One operation. You have to do at least one operation, right? Ooh. Oh, num1 is, yeah, you have to do at least one operation. So yeah, that's one operation. So we say num1 minus num2 times k, while this is larger equal to k. Okay. Int num bits equal to, I actually don't know how to do. How do we get number of bits? Get number of set bit in integer. Built-in pop count. All right, so this is going to be num1 minus num2 times k. If k is smaller or equal to num bits, k plus plus, right? So I think I can just return k. I don't have to use a res. That's a first step, second step, third step, right? And then k plus plus. And once it's bad, do you return k? Ooh, that is a good question. You might need to start with a 0, man. Oh no. If it's successful, it's here. If it's not successful, it's here. All right, we're gonna give this a shot, but I don't have very good proof, but vaguely I feel like that should be right, and it is not. Output 1. Yeah, that's interesting. Oh, this has to be larger equal to, my bad. Why you do this? I can just put it here. Save another line. All right, we can try it. I feel like it should be right, but don't have good proof. We overflowed. Oh, Lord. Oh, I did not expect that. Really? Maybe, hold on. Maybe we long this. Actually, Oh. All right, maybe do this. Long n1, n2. Not sure. Oh, I don't know. Maybe we should use bit set. Bit set bits. Okay, let's use this bit set. Well, we go 64, buddy. Right, bits.count. How about this? Yep. Some trick. Yeah, we got this, but man, it's don't have good proof, but I know it's correct. All right, let's see. What's the proof? Whether x can be expressed as the sum of k power of 2. Let fx be the number of ones in the binary representation. For k to be valid, the following must be true. K is smaller or equal to x. Yes. This is the upper limit of k. And k larger than x, even if k higher. Yeah, that's true. K is larger than, this is the lower bound. Yes, that's exactly what we're doing. How x changes as k increases. When x smaller than k occurs, long x. I don't know. I mean, and it doesn't really have a proof. It just said when k is within this, and then it can definitely be. Oh, okay. It actually says. Yeah, it just say if you can use more. Okay, yeah, that's fine. But built-in pop. Oh, LL. That's okay. LL. Okay, that's not too bad. All right, 30 minutes, exactly as we planned. All right, I will